Okay, this is 7.1 part 2. We're going to do some rational exponent properties, and the first one I already showed you. So the first rational exponent property is the fact that if I have a base, my exponent is a fraction m over n. The bottom number is the index number, and the top number is the exponent of the base. And now there's two ways to write this. You could say the nth root and then a to the m, or you could have the nth root of a with an exponent outside of it. That is equivalent. Another thing you should think about is that this means that I could think of it this way. It's like 1 over n times m. That might kind of help you out a little bit. So just a reminder from the other video, a to the 1 over n power is the nth root of a. And let me translate this to a negative exponent. So a to the negative m over n. We learned before negative exponent translates something to the bottom. We're going to review this more in section 7.2. And then same rules apply as before. So it's the nth root and then a to the m power. Here's how we're going to use this. Knowing some properties of fractional exponents, I can solve a statement like 9 to the 3/2 without using my calculator. And you are allowed to use a calculator for the test or quiz, but as much as possible, see if you can do it without. Alright, I said earlier, the bottom number is our index number. When I have a 2, that's really a square root. It's just so common, they don't write the 2 usually, but really I've got the square root of 9 with that. Then the top number gives me my exponent. So my exponent of that whole statement is 3. And now what I'm thinking is, okay, square root of 9, I know that is 3. So really I'm trying to find what 3 cubed is, and 3 cubed is 27. That is my answer. Part B, 32 to the negative 2/5 power. So again, I'm thinking, okay, bottom number is my index number. Top number is my exponent. We'll deal with that negative in a minute. For now, the 5th root of 32 is 2. What a negative exponent does is it moves it to the bottom of the fraction. And again, we're going to talk about this more in section 7.2. But this becomes 1 over 2 squared, which is 1/4. Pause the video and try C and D. Here's what I'm getting. 4 to the 5th power, which is 1024, and then part D, (1 over 16). Just a few quick comments for you about calculator usage. Let's suppose that instead of doing it on your own, you are trying to use your calculator. Quick comment, you should know that 9 to the 3/2 power, to enter that into your calculator, we need to use that caret key. It's right underneath the clear button, and then the fraction, put it in parentheses. Otherwise your calculator won't know that you want the whole fraction to be part of the exponent. One more comment I want to make. In general, if you have an odd exponent for an exponential statement, you're going to have one answer for your problem. We're going to talk about these in a little bit. An odd exponent equals one answer. For example, let's say I had x cubed equals 27. Here's what I mean. There's only one thing that I could put in for x to make this a true statement. The only thing I could use is 3. So there's only one answer. See, if you did a negative 3, it would be negative 27, which is not equivalent. The other thing you should write down is that if I have an even exponent, it's kind of like saying it's an even index when I'm taking the roots, but an even exponent, there are 2 answers. For example, if I had x squared equals 9, I could either have 3 squared equals 9, or I could have negative 3 squared equals 9. And one more quick comment, you need to be careful in your calculator because negative 3 squared in parentheses is not the same thing as negative 3 squared without parentheses. It doesn't work. Try it if you want. All right, example 3. We're going to use this fact about roots that we talked about just a little bit earlier to solve some equations. So, flashback again to geometry 2. What I want to do is get my x term by itself, and then I'm going to take some sort of root to get rid of the power. So in this situation, I'm going to divide both sides by 2. I end up with x to the 4th equals 81. And now, in order to get rid of the power of 4, I need to 4th root both sides. And this is what I meant by when you're taking an even root, a 4th root, we're going to have 2 answers. So the roots are positive or negative 3. And that's my answers for x. One comment I want to make, this is true, so the same pattern holds. So like if I had an x cubed, take the cube root to get rid of it. If I had an x squared, take the square root to get rid of the x squared. And every time we're going to get the variable by itself before we root it. Now if I look at example B, this entire statement is considered the root, or sorry, I meant the variable. So this entire thing is considered the variable. So this is actually right away ready to be rooted. So right away I would take the cube root of both sides. And again, taking the cubed root cancels out the cubed. So now I have x minus 2 equals the cubed root of 10. What you want to think about right now is, do I have 2 answers here or 1 answer? And what I'm looking at again is the index number. So if it's odd, there's only 1 correct answer, not 2. I'm going to add 2 to both sides. And if I type that into my calculator, I actually get 4.15. And by the way, we're going to get approximate answers for some of these. If I wanted to give the exact answer, it would just look like this. So there's the exact answer. Here's the approximate answer. Whenever you need to round today, round to the nearest hundredth. That means 2 decimal places. I'd like you to pause the video and try C right now. Unpause when you're ready to check your answer. You should be getting x equals positive or negative 2. Here's how I did that. Divide by 5, take the 4th root, and because it's even, I've got 2 answers. I'm going to go through D because this one is a little bit more tricky, but again, we got to get the quote variable by itself before I can take a cube root. So in this situation, this whole thing, x minus 1 cubed, counts as the quote variable. So I'm going to use normal equation solving skills, which means you usually are doing order of operations backwards. So first I'm trying to add over that 12 to get rid of it. 116 plus 12 is 128. Now I'm going to divide by 4 on both sides. 128 divided by 4 is 32. And now I'm at the stage where my variable is by itself. And because it's a cube, I'm going to cube root both sides. I've got x minus 1 equals the cubed root of 32. And then I'm going to need to add 1 to both sides. So the cubed root of 32, and then I'm going to add 1, and I'm ending up with approximately 4.17. So that's our approximate answer. And I just typed into my calculator cubed root of 32 and then plus 1. Some calculators, depending on your model, you may, when you type this into your calculator, you may need to do a close parentheses after the 32, depending on your calculator type. Alright, for this lesson, 7.1, we learned about how to find the roots, we learned about simplifying with a fractional exponent, and we learned about solving each equation by using the nth roots. Yay!